So today, guys, we are talking about plate tectonics. The basics is our very first lecture in the plate tectonics unit. Let's see what we have going. We want to review the structure of the planet Earth. We have the three main layers. We have the core, the mantle, and the crust. There are two types of crust. We live on the continental crust. The continental crust is different from the oceanic crust in several ways. The continental crust is much thicker, it is less dense. So, in other words, it floats, it would go on top of the oceanic crust. The continental crust is mostly old, and we'll find out why shortly here. The oceanic crust is much thinner. It is dense. In other words, it's heavy. It will sink underneath. So, if this is a continental, this would be the oceanic sinking under. And it is younger than most continental crust. So, this here is the ocean. This is a continental crust underneath the ocean, to be clear on that. What is plate tectonics? It is a branch of geology concerned with the structure of the crust of the earth and the formation of the folds and faults in it. Plate tectonics, the basics. The Earth's crust is divided into 12 major plates, which are moved in various directions. These plate motions causes them to collide, pull apart, or scrape against each other. If you look at the map of the world, you can see on how this, like the nose of South America here, kind of fits right there, and how the big bump here on Africa would fit in here where Central America is. That's because they are actually sitting on plates. And here you can see they fit even better because there's the plates. What are these plates made of? The very top is made of the lithosphere, and that is the crust in the upper part of the mantle. And so this part is thick and floats on top of the more liquid part of the mantle. The layer below the lithosphere is the asthenosphere. Do not confuse it with the atmosphere. The atmosphere is what you are breathing. You don't want to breathe semi-liquid rock, right? That would be very bad. So the asthenosphere is made up of mantle, which is a liquid rock. It's a semi-liquid because rock is very slow. It's not you're not going to pour it quickly out like water. The plates of the lithosphere are moved around by convection cells. So think about like boiling water. The inner and outer core is extremely hot. And so the magma comes down here and gets heated up, like your hot water gets heated up by the bottom part of your stovetop. And then that part gets pushed up. And then that causes it to be moved. And then that causes the entire plate to move. Now we're going to talk about that pushing and pulling at the different boundaries and what we call those. And we're going to get going. And we're going to talk about each one of these in more detail. So on your note guide, there's just a little bit about each of these, and we get into greater detail. So remember that divergent means to go away. You diverge your thoughts or from your parents as you get older, or you can converge. You may have thought you felt very differently about things now, and maybe one day you realize that actually you and your parents think similarly. To transform boundaries, it means they are sliding by each other. One's moving this way and one's moving that way. Okay, so going back to more information on divergent boundaries. As these are moving apart, it's called rifting. They are rifting apart, and new material has to move up because there's an empty space, and you can't have an empty gap down to the center of the planet. So the liquid mantle comes up, it forms volcanoes and new sea floor. So new sea floor means new sea crust. So this is why you get newer oceanic crust, is because all this is new material in the middle, and because the oceanic crust is denser, it ends up getting recycled faster. It goes underneath the continental crust and then is melted down. There is one place where you can actually see continental rifting, and that is Iceland. So if you go to Iceland, you can actually see where it's being pulled apart very slowly, about as fast as your fingernails grow. And so if you go there, you can actually see this. Right here, it's actually going right outside the town. These are night pictures because they're so much cooler to look at. And here's all the little volcanoes that pop up because of that rifting event. Convergent boundaries have three different what things that can happen, because you can either have continent versus continent, continent versus ocean, and ocean versus ocean. When we have continent versus continent, we get mountains forming like the Himalayas or the European Alps. And what happens here is one of the continents is a little bit more dense and it goes underneath the other one, and we get the whole ridge of new mountains. And here's the Himalayas. So at one time, India was a island continent, so to speak, and about 71 million years ago. And here we see that 10 million years ago is when it first touched the Eurasian plate. And then today, we now have the Himalaya Mountains, with Mount Everest being the tallest land mountain on the planet. Vocab: subduction zone. Sub means to go under. Submarine goes underwater. In this case, subduction zone is where the more dense plate goes under the less dense plate. And so, in the case of a continent versus oceanic crust, the ocean crust is always more dense. So, the ocean crust will always go underneath the continental crust, subducts underneath. And when it gets far enough underneath, it gets hot and it will melt. And the melting will cause liquid magma. And then that goes up because some of it is lighter. And that causes a ridge of volcanoes to form. And we can see this in the Andes. We can also see this out west. So a lot of the mountain ridges out west were volcanoes. When we have ocean versus ocean, both of them are dense. And so we have it coming together, and they're going to form a trench. And we get the deepest parts of the ocean at these places, like the Mariana Trench. And we get some really strange animals that live in these very deep places. Transform, the last type, where they slide past each other. This is the San Andreas Fault, which is a transform boundary. And right here, this is like an infrared where we can see this is a stream. And you can see that this stream at one time would have been together. And eventually, it's going to form a deep meander here. But this is like right after an earthquake. So there's literally been a big shift. And now they don't actually touch each other. So transform boundaries result in earthquakes along those fault lines. And of course, the most famous around here anyway would be the San Andreas Fault. Not near here, but in the United States is the most famous. That is all the notes about plate tectonics, the basics. I will talk to you soon.